All right, guys. So an object's position time graph shows a lot of information about what is going on. It shows a lot more information than we can just glean from the surface. So we're going to examine this graph and we're going to describe the motion in each section. And then at the bottom, we're going to write a story about what's going on in this graph or what we can tell is happening in this graph based off of what we see. So the first thing I see when I look at this graph is I see these 4 sections that are completely straight. So I'm going to highlight these green because they're completely straight. And I want to be able to see when I go to write my story where these sections are. All right. And when it's completely straight, it means that the object is stationary. So we have a horizontal line. We're stationary. I misspell that word every time. And our velocity is 0 meters per second. All right, the next thing I notice is the areas. If you're me, I'm going to go for the easy things first. The next thing I notice when I look at this is the areas where it makes a straight line, right? That's the easy part. For some reason, I thought it'd be a great idea to highlight it in yellow on my sheet. Yellow isn't going to show up in the projector, so I'm going to use pink. So here's where I have a constant velocity, and I have another one down here. All right, so it's a straight line. And it's got a negative velocity or a negative slope. And it says up here that this positive is east. So this must mean the person is traveling west. So we have a constant velocity west. All right, so let's go up here and let's look at this one. Again, we've got a straight line. It's got a positive slope. And on this graph, positive is east. So we're going to say we have a constant velocity east. All right, next we need to talk about what a tangent line is. So a tangent line is a line that touches the curve at that one point. And at that one point only. So if this was my curve, my tangent line would touch it at just one point. So if I were to draw tangent lines here, I can't put them on this side because if I draw a tangent line on this side, it's going to intersect it when it gets up higher and lower. So my tangent line would be here. There'd be another one here. There'd be another one here. We already said that when we see this curve, we know that the velocity is changing. So we've got a changing velocity. Sorry, it doesn't fit in the box. And the slope of that tangent line is getting bigger and bigger and bigger. My little lines I'm drawing are getting more and more and more. So they started off kind of like this, and they're getting more and more steep. So because the tangent lines are increasing, we know we have a positive, or we have acceleration. All right, so now we're going to go over here, and we're going to look at this curve. All right, so if I were to draw my little tangent lines here, they're kind of hard to see in pink. Let's see if this purple is a little bit, nope, it's just a sharp. All right, so my first tangent line is here, and then my next tangent line, and my next tangent line. So they started out like this, and they're turning ever so slightly. They started out steeper. They're getting steeper and steeper and steeper. So we have a curve, so we know that we're changing velocities. And even though it seems like that might indicate deceleration or that we're slowing down, we're not. We're still accelerating because the slope of the tangent line is increasing. But as it's increasing, it's becoming more negative. So since it's becoming more negative, we know we're accelerating in the negative direction, or we're accelerating west. All right, last but not least, let's look at this last little curve we have. So it's a curve, so we know that velocity is somehow changing. And if we look at our tangent lines, here'd be our first, our second, our third. They're getting more and more and more flat. So the slope of the tangent line is decreasing. So because the slope of the tangent line is decreasing, this is when we decelerate or slow down. All right, so now it looks like we have labeled all of the parts of the graph. What's going on in every little part of the graph, we have labeled. So we need to prepare a story about this. It can be whatever kind of story you want. So I'm going to say we need to figure out where we're starting. So 1 is at the very beginning of the graph. So 1, I'm stationary. How long am I stationary for? 0, 10. So I'm stationary for 10 minutes. So let's say Red Riding Hood is stationary for 10 minutes while she packs food. All right. The second thing that happened on my graph was we had a change in velocity and we accelerated. And we accelerated east. And how long did we accelerate it east? We accelerated east for 10, 20 minutes. For the next 20 minutes, I'm going to abbreviate Red Riding Hood, RRH. Red Riding Hood walked to Grandma's house. But what do we know about what happened as she walked to Grandma's house? We know that Grandma's house was two things. We know that Grandma's house was east of her house. So she slowly walked to Grandma's house. You can either put the east of hers. Side note, as she walked, she got more excited and sped up. After all, she's going to Grandma's house. That's super exciting. Red Riding Hood's going to Grandma's house. All right. Step number 3 is right here. It's the next thing we see. It's a straight line and a constant eastward velocity. So Red Riding Hood realized if she didn't slow down or if she didn't keep a constant pace, she would get there too early. So Red Riding Hood walked at a constant pace east for, how long did she walk at a constant pace east? About 10 minutes. So she wouldn't be early. Four. The fourth thing that happened is we were stationary again, and it looks like we were stationary again for 10 minutes. So Red Riding Hood arrives and confronts the big bad wolf for 10 minutes. But where is she stationary? She's stationary at 2.5 kilometers east of her house. So we know she's 2.5 kilometers. I put the brackets in the wrong place, Miss Neal. She's 2.5 kilometers east of her house. So if I had more room to write, a more correct sentence would say Red Riding Hood arrives at Grandma's house, 2.5 kilometers east, and confronts the big bad wolf for 10 minutes. So I'm adding in that location to make it more correct because that graph is showing me where Grandma's house is. Grandma's house is 2.5 kilometers east. Uh-oh. The next thing that happens is number 5, and Red Riding Hood realizes the big bad wolf is there to eat her, and she needs to get home. So how long did Red Riding Hood run home? It looks like she spent not quite an exact 10 minutes, so we'll say 15 minutes. Red Riding Hood runs west away from Big Bad Wolf, picking up pace for 10 minutes, or 50, we said 15 minutes. But Red Riding Hood, man, she's had a busy day. So the next arrow we get to on our graph is 6. So Red Riding Hood, it has been a super busy day. So Red Riding Hood continues running west, but slows down for the next how many minutes? It looks like it's about 15 again. All right. Step 7. Red Riding Hood is out of breath. She needs to take a break. So I'm going to grab another sheet here really quick. So step 7. Red Riding Hood hides behind a tree and where is she? Is she at a tree in the middle of the forest? No, she's at a tree back at her house. She's back at 0. So Red Riding Hood hides behind a tree at her house for 10 minutes. She didn't want to hide inside her house because if she hid inside her house, the big bad wolf might find her. So she hid outside behind a tree. But that's not the end of our story. Eight. Red Riding Hood travels now to, who else can live in the forest? Bear's house. I guess it'd be the pig's house, right? Let's do one of the 3 little pigs. To Pig's house. And where is Pig's house? Pig's house is 2.5 kilometers west at a constant velocity It's a fairy tale after all. She has one of those cool, awesome automated cars. How long did it take her to get to Pig's house? It took her 10, 20 minutes. It took 20 minutes. Number 9. Red Riding Hood spends the day, or spends the next, not the day, 10 minutes hiding in Pig's straw house And where is Pig's straw house? 2.5 kilometers west of hers. All in all, if we wanted to give like an overall synopsis of the story, Red Riding Hood was at home for 10 minutes. She traveled to Grandma's house and she got excited for the next 20 minutes, so she sped up, for 20 minutes, yeah, so she sped up. Grandma's house was east of her house. Then she realized she'd be early, so she walked at a constant pace east for the next 10 minutes. When she got to Grandma's house, 2.5 kilometers east of hers, she confronted the big bad wolf and screamed at him for 10 minutes. Then she ran away from the big bad wolf for the next 15 minutes. And as she ran away from him, she got faster and faster and faster because she was scared of the big bad wolf eating her. That went on for about 15 minutes, and then she got really tired. So she slowed down for the next 15 minutes. She was still running away from the big bad wolf, but she reached her peak velocity and now she was slowing down. And finally, she got back to her house and she realized the big bad wolf was still after her. She was back at her house and she hid there for 10 minutes. After she hid behind her house for 10 minutes, she realized she needed to get away. So she got in a constant velocity vehicle, maybe an automated scooter that has like a set speed, and she headed away from her house. The direction she heads in now is west. She headed west at a constant velocity for the next 20 minutes. And she was heading for Pig's house. And Pig's house lived 2.5 kilometers west of hers. When she got to Pig's house, they hid for the next 10 minutes and they didn't move. So all in all, her day so far has only been 120 minutes. That's only 2 hours. So we still have the rest of the day to go. If you wanted to keep going, you could tell the story about how Little Red Riding Hood and Pig ran from house to house to keep escaping that big bad wolf. And I'm sure we could finish the day off in a few hours. If you have any questions, let me know.